So now let's substitute the value of F is equal to V over F in the above equation. So when we substitute F to represent V over F, so what's left in the equation is XF equal to Y star F plus X star 1 minus F. So that will give us an equation which is a straight line equation represented by Y star is equal to F minus 1 over F X star plus XF over F. So this equation, which is equation of straight line, will represent the line or the operating line for the given condition. So this is as if you can see the slope of the equation, the slope of the straight line is given by f minus 1 over f, and the y-intercept of the particular operating line is given by xf over f. Let me remind you again, the value for F is equal to V over F. This is the ratio of vapor to the feed. Okay, so the unit should be the same if you're talking about mole per hour for the vapor, and for the feed also mole per hour, so that you get a ratio. So small f here represent a ratio of vapor amount and the feed amount. Now let's look at the equilibrium graph. So you need to sketch the equilibrium curve based on the equilibrium data given in the questions. Okay, so you're going to get a few sets of data that consists of the mole fraction of component A or more volatile component in liquid phase and more volatile component in vapor phase. So you're going to plot on a graph which is vapor, mole fraction of the vapor versus mole fraction of the liquid for more volatile component. Bear in your mind the range of your x-axis is 1 and the range for the y-axis is also equal to 1. Next, you need to draw a straight line. So this straight line is called 45-degree lines. So after you plot all the coordinates that you have in the equilibrium data, you're going to connect all those coordinates until you get a smooth curve. Then next is for us to look at the operating line. So when we want to draw the operating line, you must begin at the 45-degree line where the mole fraction of the liquid in the feed is drawn vertically for this particular axis. So starting from this point, you can draw the operating line. The operating line is given by this particular equation. So how do you want to draw this line? It's very simple. Just find the y-intercept of this operating line. If you know the y-intercept of this operating line, you just connect this particular y-intercept with the intersection between the feed and the mole of the feed for volatile component with the 45-degree line. So next, you just connect the 2 points until you get a complete set of straight line. When you draw this operating line, you can see that this operating line will intercept with the equilibrium curve. Okay, so the point where it's intercept at the equilibrium curve will give you the value of y star and the value of x star, where this represent the equilibrium phases between liquid and vapor of that particular mixture. Okay, so again, let me remind you the value that we get here all represented by the volatile component, which is for A component. Okay, so now you can solve X star and Y star. So this is the equilibrium component of vapor and liquid for volatile component.